So this is going to be quite a sort of broad brush, big picture talk about how I see what's at stake in choosing between logics and what kind of methodology we should use in doing so. My general approach is a form of anti-exceptionalism about logic. So I don't take logic to be terribly special. It's something more like one component amongst many in science, very, very broadly understood as some kind of systematic inquiry into the nature of reality. But if we think about it like that, then an obvious question is, well, what is logic about? Of course, some people want to say that it's about reasoning. I don't find that at all a satisfactory answer. Of course, if it's meant to be some sort of descriptive inquiry into how we do reason, then that's something surely for psychology rather than logic. And if it's meant to be a prescriptive inquiry into how we ought to reason, that still strikes me as unwarrantedly psychologistic in giving the process of reasoning too important a place in the account of logic. I mean, it's a bit as if somebody said that what physics is about is how we ought to reason about the physical world, or how we ought to think about the physical world, which is kind of true, but it's also getting the cart before the horse, because we better find out something about how the physical world is before we start laying down the law about how people should think about it. And it seems to me that the situation in logic is somewhat similar to that. So a less psychologistic answer to the question is that logic is about the relation of logical consequence. But of course the question is, what's that? And I don't find plausible the approach that you sometimes find in the literature, where people take it that we've got, as it were, some kind of pre-theoretic way of understanding of the notion of logical consequence, and then what we've got to do is to analyze that or theorize about that on the basis of our intuitions about particular cases. I mean, that seems to me an unwarranted, an unwise way of setting up a discipline, because, of course, although we do sometimes talk about what follows from what, not just as theorists, but just as ordinary thinkers, the notion of following there, we shouldn't expect to correspond to anything as pure as logic is normally supposed to be. I mean, we've got some interest in reasoning well, but that doesn't mean that we have to be faithful to some criterion of purely logical consequence. There might be all sorts of good reasoning that are not logical ones. And so if we take it that what we're trying to do is not to be faithful to some sort of pre-theoretic notion of logical consequence, but to some more theoretically given notion of logical consequence, then of course the question is which one. And and I think that is, at least in large part, a question of what kind of relation is it going to be fruitful for us to theorize about. And the development of logic doesn't give any very straightforward answer to that question, because if you just look at all the things that go on under the name of logic, and model theory, proof theory, set theory, recursive function theory, and so on, I mean, you're not going to get a univocal answer from that. And in fact, I don't want to be very imperialistic in the claims that I'm making. I think lots of very diverse activities go on under the name of logic, and I'm not claiming that what I'm going to talk about is the only one that is entitled to that label. But I think when I've explained it, I think it's clear that it's one of the things that needs to be done, and the label logic is as good as any for it. So the starting point that I find quite useful is the theory of logical consequence that Tarski put forward in the 1930s, which is sometimes called a model theoretic, the model theoretic notion of logical consequence, but I think that's a very ahistorical description of what Tarski is doing in the paper that he published at that time, even though it's tempting because, of course, Tarski was one of the great figures in the development of model theory. But I think the evidence is that in the paper in the 30s, he's not thinking in model theoretic terms, but in terms that correspond more closely to something like the Russell and Whitehead Principia Mathematica type theory, something along those lines. But we don't need to go into the details of that for present purposes. So, just to give a very quick sketch of Tarski's approach in that paper from 35-36, which I guess many of you are familiar with anyway, but it's useful to go over it. Suppose that we have a language and we want to define a notion of logical consequence for it. The first thing that we have to do is to draw a distinction amongst the atomic constant expressions of the language between those that we're going to regard as logical constants and those that we'll regard as non-logical constants. And I'll say something more about that distinction in a little while, but for the time being, let's just take it as given. And then if we've got an argument with a set of premises and a conclusion, what we have to do to determine in principle whether the conclusion is a logical consequence of the premises is this. I mean, suppose, for example, that the argument is from everything is F to something is F. The first step that we take is to replace all the non-logical constants in the argument by corresponding variables of the same type. So if I just use an uppercase X for that, we will get that. And then the criterion for the conclusion to be a logical consequence of the premises is that every assignment of values to variables that satisfies all the premises, makes true all the premises, also makes true the conclusion. So in this case, let's suppose that we've just got this one non-logical constant, the predicate S, which might be a frog or whatever, and then of course, in that case, we've got a true premise. We've got a false premise. Depends on the debate. We've got a false premise and a true conclusion, but what but we can assign an empty extension to the higher order variable x, uppercase x here, and we can get actually in this, this is an interesting case, because if this argument is actually going to come out valid on the criterion that Tarski is using, because there's actually no restriction to a domain here, so this is already a way in which we'll get an unusual case. But let's not focus on that aspect, because he'll be understanding the quantification as quantification over all individuals, and then we can assign to this variable, anything, whatever we assign, if the premise is true, then it applies to all individuals. So there are some individuals, so the conclusion will be true as well. So that's already a way in which it's different, at least from a version of the model theoretic approach on which you're allowed to have the empty domain. So the crucial thing is just that we get a certain kind of generality on all the non-logical bits of the argument. And in particular, if we're talking about an argument with no premises, then we can think of that as being a logical consequence there, just in case the conclusion is a logical truth. So in this case, if the corresponding thing would be if we just took the conditional, if everything is f, then something is f, and so we'd be evaluating the conditional if everything. Sorry. Oops. Everything is x, and something is x, where we're allowed to assign any value to the higher order variable x, of course of the right type to this, and this will always come out truth, and that means that the original sentence counts as a logical truth, because it's equivalent to a consequence of an empty set of premises. Now, so that's a kind of general picture that Tarski's giving. And one thing to notice is that if we have a higher order quantifiers, possibly by extending the language, what we could have done is explicitly quantified on the variables that we introduced to replace the original constants, and then the logical truth of the original sentence would be equivalent to the simple truth of the universally quantified sentence that we got once we stick the variables in for the constants. So, as it were, this one is logically true if and only if this one is true. So what we're in effect looking at least in the case where we're considering logical truth, is in effect the simple truth of certain universal generalizations. By the way, it's worth noticing another aspect of Tarski's account, that if we don't have any non-logical constants in the original sentence, then as well there's nothing to generalize on, and so the sentence will just trivially count as logically true if and only if it's true. For example, if we took the sentence there exists x, such that there exists y, such that x is not equal to y. In other words, there are at least two things that, assuming that we're treating identity as a logical constant and all the other things there, this will be something with no non-logical constants in it, and so it will be logically true simply because it's true. And this is a consequence of the account that Tarski himself draws in the paper, which is one that tells you that he's not tacitly assuming that this is all relative to domains of quantification, because if it were, this would not come out as a logical truth, but that's by the way. So what interests me here is that we've got, if we're asking questions about which sentences are logically true, that's equivalent to asking which generalizations of a certain kind are true. So that, as it were, so the investigation of logical truth is in effect an investigation of the simple truth of certain very general generalizations. And it seems to me that that's a kind of investigation that we've got to have. Whatever we call it, whether we call it logic or not, we've got these very general generalizations. And it's just, as it were, part of our systematic investigation of how things are, that we want to know which of these generalizations are true. Now, if I put it that way, it can look as though this account, which, it seems to me that the natural thing to call this investigation, when we're dealing with generalizations of this level of generality, is logic. And it might sound, from the way I put it, as though I've set up logic as a metalinguistic investigation, because it's an investigation into which sentences of a certain kind are true. But I think that's actually just an artifact of the presentation. It's rather as though a physicist were to give you various generalizations, true or false, about mass and energy and so on, and then say, well, physics is the discipline which investigates which generalizations of this kind are true. And if you thought, oh, so physics is a metalinguistic investigation because it's interested in which sentences of a certain kind are true, you'd be kind of getting the wrong end of the stick, because really the reference to the truth of sentences there is just a convenience, and if we're going to be faithful to the spirit of the enterprise, we should just strip it away. So, we should say more long-windedly, we're interested in things like, is it the case that blah, 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 where followed by some kind of physical generalization, and then in the case of logic, it's, we're interested in things like, is it the case that for all big X, blah, 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 blah. So that, in fact, to say correctly what kind of questions we're interested in answering in this inquiry, we should remove the truth predicate and just, as it were, if you like, ask the questions in the extended object language. Extended simply because we may have had to add higher order quantification in order to make explicit the kind of generality that we want. The higher order quantification is not in any way any more metalinguistic than first order quantification. So that's the kind of non-metalinguistic fundamental inquiry into certain kinds of generalizations that I think is one good thing for logic to be. And if we ask, well, what's this about? I think the natural answer would be, well, it's an investigation into, for example, universal generality identity, conjunction, not in the sense of linguistic expressions, but of what's expressed, negation, and so forth, and in particular to the very general structural features that this subject matter exhibits. Now, one thing that I haven't yet said is what we should count as a logical constant for these purposes, because in effect the logical constants are the things that express what this inquiry is to be about. Now, one approach to that is to, as it were, to try to fix on, once and for all, onto a set of expressions which have some nice feature that we regard as the mark of logicality. And in fact, in a later paper, Tarski made a suggestion along these lines. He proposed a criterion of invariance under permutations of the individuals in the underlying interpretation, which seems, to be a reasonable stab at a criterion if that's what you're looking for. But given the way I've set things up, it seems to me unnecessary and in fact inappropriate to have a once and for all criterion of logicality, because what the criterion is in effect doing is determining the subject matter of our investigation, and that to some extent is just a matter for us, so what we're interested in. So for example, in my book of Modal Logic is Metaphysics, I was interested in the logic, in quantified modal logic, under an interpretation of the box operator, modal logic, as standing for metaphysical necessity. And so for the purposes of that investigation, it was important to treat the box as a logical constant, simply because I wanted to keep its interpretation fixed, not to, as it were, generalize it away, because that was what I was interested in, or a large part of what I was interested in. But there's nothing wrong with somebody carrying out a different investigation where they don't care about metaphysical necessity. That's not part of what they want to focus on, and for their purposes, it might be that some way of generalizing away the box would be a more appropriate thing to do. So I think the most fruitful attitude to the question of what to count as a logical constant is just a pragmatic one, that it's up to us in defining our subject matter. I mean, of course, some choices will be more fruitful than others in repaying a kind of a sort of approach that uses the kind of techniques that are common in logic. So, I mean, there are constraints of that kind, but that they still leave quite a lot of leeway, and it seems to me that's entirely as it should be. So I take it that what we're concerned with is certain kinds of theory of this incredibly general kind that might involve generalizations like this one. And I take it that the appropriate methodology for this kind of investigation is in general an abductive one, where we're concerned with the comparison between alternative theories according to criteria such as simplicity, strength, fit with the available evidence, explanatory power in some non-causal sense of explanatory, as our ability to bring all sorts of different things under illuminating generalizations. Those kind of criteria. I'll leave it pretty schematic as well exactly how to understand them. And that's how, those are the kind of criteria we're going to be using in choosing between alternative theories. I mean, I think often when people are thinking about the comparison between different logics, they're thinking of logics for a bunch of expressions where we're supposed already to have a logic that we fixed on as the right one, and then it's just a case of whether it can beat off challengers or something like that. But that is not the general case in logic. I think the case of quantified modal logic is a good example, because there we haven't really fixed on any one specific quantified modal logic. I mean, it's transparently a matter for some kind of investigation about what the right logic is for, of course, for a given interpretation of the modal operators. One thing that I've been doing, which you may have noticed, is that having started by talking about Tarski's theory of logical consequence, I've focused on the special case of logical truth, because that was where we were able simply to universally generalize on the relevant sentence with the variables put in for the logical constants. And so I've been leaving out the case of logical consequence for arguments which have more than zero premises. Now, in some circumstances, it's pretty clear what we need to do, and quite easy to bring that under the approach that I've already described, because what we can say is that if we've got an argument with a set of premises gamma and a conclusion alpha, that will be equivalent. Whether that's alpha is a logical constant of gamma will be the equivalent to whether a conditional with the conjunction of all the sentences in gamma as the antecedent and alpha as the consequent is logically true. And this may, if gamma is an infinite set of premises, then we may have to introduce some kind of inferentiary conjunction, but I mean, we know how to interpret those. And so, for example, in the case that I was interested in of quantified modal logic, that was an appropriate thing to do, because it was being held fixed that we were using some classical propositional non-modal logic in the background, and so these things would just be equivalent. And so, for those kind of purposes, we can quite easily sort of assimilate the case of logical consequence to the case of logical truth, and then of course we can start universally generalizing conditionals like that. But that way of treating logical consequence doesn't work in general, and it particularly doesn't work when we're concerned with non-classical propositional logics, and where they're being non-classical about the non-modal part. And in fact, of course, here, as I'm sure most of everybody knows, there's a lot of interest in logics which look exactly like classical logic as far as the set of theorems go, but when you start looking further, actually they behave non-classically. Actually, in some cases, they may even look like classical logic as far as logical consequence goes. Where the differences may be further back in the structural rules. I'm not going to go into the details of that, but it's clear in general that that you can't simply evaluate logics by looking at their set of theorems, because you can have logics with a standard set of theorems, but with incredibly weak inference rules, where you can hardly make any further inferences. But that won't come out as a limitation if you just look at the set of the theorems of the logic. And so this is a place where what is sometimes called the closure role of logic becomes important. And and I think that comes very naturally in the kind of approach that I'm talking about, because we're not simply interested in logic as some kind of isolated inquiry. We're also interested in it as a background theory for all sorts of other theories, because we need logic to derive their consequences. So if we've got some kind of physical theory, and we want to make predictions from it, then we have to derive consequences from the physical theory, and so we need some logic to do that with. And so I think the natural thing to do is, when we're evaluating logic is not simply to look at them as theories in isolation, although that's part of what we'll do, but also to look at what the effect of is using them as a background logic for non-logical theories, e.g. physical or mathematical theories. And so we're seeing what we can get out of them, and using that as a way to differentiate between logics which may look the same when we just look at the set of logical truths. And so that seems, as it were, very much of a piece with the kind of approach that I've been suggesting for regarding logic as just part of our general inquiry into reality, as it were, just one part of general science. One thing I want to comment on at this stage is the fact that you may have noticed that in characterizing logic this way, or at least as well, the part of logic, the form of logical inquiry that I'm concerned with in this way, I have not assigned it any special epistemological privileges whatsoever, because we've just been talking about the truth of certain generalizations. So in particular, nothing that I've said implies that there's anything specially a priori about logic. I mean, it may, as well, for all I've said, be that some parts of logic are in fact a priori, but that isn't any part of the characterization. And of course, that also means that we can't take it for granted that logic in this sense plays any special normative role that you might think it would play if logical truths had some special epistemological privilege. I mean, as it were, it no more it intrinsically governs rationality than physics governs rationality, if you like. And it's no more, as it were, it has no epistemological status that would enable it to be, have some special role, for example, in the evaluation of combinations of assertion and denial. There may be logical truths that are utterly inaccessible to our knowledge. I mean, for example, in second-order logic, one can formulate a version of the continuum hypothesis and a version of its negation, and one of those, on the view that I'm suggesting, is true, the other is false, but we may be completely unable to know which. So I take it that this kind of epistemology-free approach to logic is actually an advantage of Tarski's account of logical consequence, not a disadvantage, because it, as it were, keeps the subject matter of logic clean, so that we don't have to worry about the kind of all the messiness that comes with epistemological considerations. And also, just from the perspective of this kind of broadly realist approach to logic, the idea that we should constrain the subject matter of our investigation by its susceptibility to being known in a particular way, e.g. by a priori reflection or whatever it's supposed to be, seems very strange indeed. I mean, what other discipline is constrained in that way? It's not even epistemology is constrained in that way. I mean, in the sense that in epistemology, we're concerned with knowledge as a subject matter, but roughly speaking, no holds are barred in how we find out about that subject matter. And similarly, in the case of epistemology, of logic, it seems to me that if we're interested in things like generalizations of this kind, then in principle, no holds are barred in how we find out which of these generalizations hold and which don't. So, as it were, in principle, everything in logic here is subject to testing in something like the usual scientific way. In fact, I think one advantage of the kind of higher order approach that I've been assuming, for example, in forming higher order generalizations like this, is that it enables us to articulate universal generalizations, which can then be subject to testing in the usual way, and which, for example, we can negate or make the antecedent of a conditional or embed in all sorts of ways like that, which is very different from what you can do if you're sticking to first-order logic. So, for example, in first-order logic, you have to formulate mathematical induction as a schema with infinitely many instances. And although you can do things with it, I mean, it's not the kind of thing that you can negate or embed in any of the usual ways. Whereas once you go to second-order logic, you can replace the first-order schema by a single second-order generalization, and then there you have something which you can test and embed and so on, and as it were, apply all the general apparatus of testing to. And I think a similar consideration applies to the choice between axioms and rules of inference. That the advantage of putting as much as one can into axioms rather than rules of inference from this point of view is that axioms are there as explicit hypotheses that can be tested, that can be negated, that can be assigned probabilities maybe, and you can somehow apply some probabilistic apparatus in this choice between logics, and all the usual things, whereas rules of inference are not susceptible to that kind of treatment to the same degree. Of course, we know from Lewis Carroll's Achilles and the tortoise, roughly speaking, that we can't completely eliminate rules of inference in favor of axioms. But I think there's a lot of advantage to putting as much in the axioms and as little in the rules of inference as we can, because of the way that facilitates explicit testing of hypotheses. So I've given this kind of account of the way I'm understanding the choice between logics, and I mean what I've been saying has not been specific to any particular logic, but I think that it's pretty clear that the classical logic, understood pretty broadly, has very salient advantages from this perspective of scientific theory choice in terms of simplicity, strength, and doing at least a pretty good job of fitting the evidence. You may think that it doesn't do a good enough job, but I mean, after all, its use in standard mathematics is the pretty strong and demanding form of test that it has been subject to. So I mean, that's not, of course, to say that it couldn't be beaten in this kind of competition by another logic, but it at least looks pretty well placed for this kind of competition. And I should emphasize that that perhaps it's obvious by now, that my view of the choice between classical logic and various forms of non-classical or quasi-classical logic is very much an immanent one, not a transcendental one. That I don't think that one should be looking for any kind of, as it were, transcendental justification of classical logic or any other kind of logic, along the lines that nothing else really makes sense, or that the alternatives are only verbally different from the original. It seems to me that there's not much going for any of those sorts of views of the comparison between logics. It's a much more as a down-to-earth question of theory choice, as it might be in other sciences, according to the fairly recognizable virtues of theories. And in particular, this framework is very hostile to a kind of approach to logic which you find in quite a bit of the philosophical literature, which treats the neutrality of logic, of some logic, as an advantage, because, as it were, it's a view on which logic serves as some kind of, as it were, neutral arbiter or umpire to adjudicate disputes between what are thought of as substantive theories in science or metaphysics. I think that kind of neutrality is an illusion, as is shown by the fact that every recognized principle of logic has been challenged on metaphysical grounds, and some indeed on grounds from natural science, e.g. by quantum logicians. But also, from the kind of perspective that I've been talking about, it's a sort of bizarre idea that that the neutrality of a logic, in other words, its uninformativeness, should be considered a theoretical virtue, as it were, that a view on which, I mean, the view that I'm opposing is in fact one in which logical weakness is a strength, and that seems to me perverse. So I don't think that, as it were, views which simply water down classical logic in order to be non-committal are really have much going for them in this framework. I think much more interesting are views which weaken the logic in order to preserve unqualified versions of other principles, or other principles which for present purposes we can treat as non-logical ones. Because there's a real trade-off in strength. And so the kind of the trade-offs that may be in question is, in some way, you weaken the logic in order to maintain some strong form of disquotational principles about truth and falsity. Perhaps also in the case of the sorites paradox, that you weaken the logic in order to maintain some kind of, let's say, tolerance principles for vague predicates to the effect that if X is indiscernible in some sense from Y, then if X is red, then Y is red. Principles of that kind. I mean, those at least you're getting something for the sacrifice of a bit of the logic. So that as with if the trade-off works, then other bits in your theory will be nicer, even though the logic is less nice, because less strong. Now, but I think there's also, though, an obvious drawback with weakening the logic in order to preserve principles about truth or about indiscernibility or relative to some predicate or something. And that is that the trade-off is between a kind of global weakening and a local strengthening. When we think of the closure role of logic, the way that we're not just concerned with logical principles in isolation, but with adding them to other theories as well, which is all part of the kind of comparison between logics that we need to make. The principles that are being preserved by that kind of weakening of the logic are quite specific ones, because in the case of the semantic paradoxes, they have to do with the theories about semantic matters, which, of course, most of our theories are not. And in the case of the tolerance principles, they're not simply, it's not just that it's for theories about vague matters, but theories with these very specific types of indiscernibility or maybe special kind of similarity predicates or whatever it is. And most of our theories are not of that kind. So what's happening is that we're getting a kind of, that all our theories are being weakened by the weakening of the logic, because pretty much all our theories need to use some of the standard logical constants. I mean, truth functions and quantifiers and identity and so on. And so the general effect of such a proposal is to weaken all these theories, because the background logic is weaker. And the trade-off which is supposed to compensate for that only concerns some special theories special theories about semantic matters or special theories about indiscernibility or whatever it is. Now, of course, one does find on behalf of these weakenings of logic the claim that, of course, we can get back classical logic whenever we need it. And, I mean, there are various ways in which this might be thought to be the case. For example, you could have some kind of default principle that you're allowed to assume in some kind of defeasible way instances of excluded middle, even though you've dropped excluded middle as a universal generalization, or you're entitled to exclude, to assume in a defeasible way instances of ex falso quod limit, but it's just that you don't form corresponding universal generalizations. You just assume them when you don't get into trouble by doing so. I think it's important to understand what a massive loss of explanatory power is involved in making that move. So it's a little bit like, imagine a physicist at the beginning of the 20th century who saw that Newtonian physics was getting into trouble. And what they did was to say, all right, well, let's drop some of the principles of Newtonian physics as universal generalizations. Let's just treat them as defaults which we can sort of invoke wherever it doesn't feel as though we're going to get into trouble by doing so. That does not look like a progressive move. It's not remotely like replacing Newtonian physics by the special theory of relativity or something, and then noting that that the Newtonian physics in many circumstances will give you good approximations to the relativistic results. Because it's not replacing the old theory by one of the same kind of strength. It's replacing it by a weaker theory plus a default. And and what physicists would be happy with the idea that you can just, as it were, default to Newtonian physics, as it were, when it looks all right to do so, but without any underlying theory that is giving you a proper treatment of what is going on, which explains at the kind of level of precision that we have from either Newtonian physics or special theory of relativity, that why we're getting these failures. So I think it's clear that you can see what a loss of explanatory power there is by thinking about the move in the reverse direction. I mean, supposing that you've been using a certain default, as it were, wherever you could get away with, and then somebody came along and showed how you could actually replace the default by a universal generalization that was actually defensible, and that gave you what you wanted. I mean, that would be a huge step forward that would give you a far more satisfactory explanatory position. And and I think this is also relevant to the issue that I was raising before about formulating principles in a way that enables them to be tested as explicit hypotheses. Because the thing about defaults is that they can't really be tested as explicit hypotheses in that way. I mean, the best, I guess, that you could do is in making them into explicit hypotheses is by putting them in the form of some kind of generic sentence. But generics are notoriously elusive and hard to deal with in any systematic way. So, what I've been giving is only a kind of provisional and schematic case for classical logic, because I haven't gone into any detail about whether, for example, somebody might think that classical logic is simply incompatible with the evidence that we have in the case of the semantic paradoxes or the sorites paradoxes or whatever it is. And there are all sorts of issues that have to be dealt with in a full accounting of the comparison between classical logic and various kinds of alternative. But that may give you some idea of why I feel pretty optimistic about the chances of classical logic under a suitably scientific comparison with its rivals. Thanks very much.